Hey, are you hiring? If you answered yes, let XenTegra Staffing help staff your IT people needs. Head over to XenTegra.com/XenTegra Staffing to find out more. XenTegra Staffing, we can staff your IT people needs. Welcome to another edition of the Citrix Session with your hosts, Andy Whiteside and Bill Sutton, your source for all things Citrix.
Hello, everyone, and welcome to episode 38 of the Citrix Session podcast. I'm your host, Andy Whiteside. I've got Bill Sutton with me. Bill's back from some well-deserved PTO. Bill, how did it go?
Went great, Andy. Thank you. Had a good time with the family down in the part of South Carolina, but we got back before it got worse. So it's all good.
That's good. That's good. We've got with us Miguel Contreras. Miguel is, we were joking before the podcast, I'm just going to call him the most important guy at Citrix. And the reason why I say that is because no matter who's driving the ship, the thing that makes Citrix is what's called ICA and the Independent Computing Architecture Protocol, also somewhat related to remote display protocol on the Microsoft side, at least it was when it was birthed. But Miguel, I'll let you introduce yourself and tell us a little bit more about exactly what you cover. But you're the HDX guy, and I don't mean the Home Depot HDX guy. I mean the HDX guy that covers what's most important to a lot of us at Citrix, which is the protocol that makes all the magic happen. You want to enlighten us a little bit more about what that means you cover?
Absolutely. So, well, thanks for having me, guys. It's always great to talk to you. And so I'm a product manager in the HCX team within Citrix. Like you said, we cover the transport and what drives the, performance, the user experience of, your virtual sessions. I specifically own the ICA stack, and that, has to do with all the nuts and bolts of what enables the ICA as a protocol, so virtual channel platform, network transport for ICA, integration with Windows authentication and things like that. I basically I'm the owner of all of that.
Well, and that's the most important thing, right? User experience is number one when it comes to IT just in general, providing access to the technologies, but specifically when you start talking about remote delivery protocols and virtual desktops that run in data centers and in clouds that aren't local, and that little connection between the display adapter and the monitor, of whatever the monitor is now traveling hundreds, if not thousands of miles across the network versus a little bitty short cable. It's what's key to our whole industry.
Yeah. I mean, to be fair, there are also, other components within the HCX umbrella. Probably, I guess the second most important one would be the graphics subsystem, which is separate domain altogether. But, I think that you put, the transport and graphics, that's, bare bones what you would consider the most important parts for a great user experience. I do not own graphics, but, we work closely together. So we're part of the same team.
Yeah, those are the building blocks, right? Those are the foundations that make up a good user experience or not a good user experience. And you throw into that the fact that you're relying on networks that historically have been unpredictable, but are becoming more and more predictable as the software gets better. Networks are also getting better. And at the end of the day, this thing that seems magical if you stop and really think about the what all has to go into it. Well, it's not magic, right? There's technology that makes it happen, but man, is it quite interesting and complex? And to the end user, it really should seem magical that what's on one computer's screen in theory shows up on another computer thousands of miles away and does so efficiently is a pretty awesome story.
Oh yeah, absolutely.
So the name of this podcast, this blog, is Enlightened Data Transport is getting even smarter and more robust. So EDT, right? Enlightened Display Transport, that's been around Citrix for a couple of years now. If you could just explain what EDT is and also help us understand the difference between that and the adaptive display protocol at Citrix or adaptive transport. Maybe I'm screwing that up. But anyway, those two terms kind of get co-mingled with each other. And sometimes I think they mean the same things and sometimes I think they're different things. Can you explain what EDT is all about and how it compares to the other?
Yeah, absolutely. So yeah, EDTs are Enlightened Data Transport. It's in a very simplistic manner, it's a network transport protocol. So it's similar to what you would say TCP. It's a reliable transport protocol. Biggest difference between EDT and TCP really being that EDT is built on top of UDP, so on top of an unreliable network layer that allows us to be a lot more efficient and more responsive because we don't have a lot of dependencies on the on the intricacies of TCP and the built-in reliability components that come along with that. So adaptive transport, it's often associated with EDT, and I guess primarily because in order to use EDT with our product, you need to enable the adaptive transport feature. There are two separate things though. Okay, adaptive transport is simply a mechanism that allows our product to basically select and decide which transport protocol to use for the session. When you enable adaptive transport today, it will tell the VDA that to use EDT as its preferred transport protocol for the session. If for whatever reason EDT is not available, then it will fall back to TCP. In the event that you connect with TCP, in the background it will try to continue to reestablish the session using EDT without any type of user interaction required. So it all happens seamlessly behind the scenes. So that's really what adaptive transport is. So
adaptive transport is the intelligence that you enable as a feature that allows it to pick EDT over TCP. TCP is what we grew up on ICA using, right? But then EDT,
correct.
And EDT, and I think you may or may not have said this, it leverages UDP as its foundation, which is a much more resilient and much more user experience friendly protocol. Think of like your VoIP solutions that you don't care what Bob said 2 minutes ago. We don't need to resend that traffic. Let's just move on to what Bob's saying right now. That's the beauty of EDT leveraging UDP, and adaptive transport is what you enable to allow it to make that decision for you. Is that a good answer?
Yeah, pretty much. The one thing I just like to clarify there. So UDP itself is actually not more resilient than TCP, right? Like TCP and UDP are basically polar opposites when it comes to resiliency, in the sense that TCP was built to be a reliable and resilient protocol, whereas UDP is just fire and forget. Right. So as a result, UDP is more agile, right? We can fire traffic faster than we can with TCP, just because we're not waiting on acknowledgements before we can say, okay, we can send the next data packet. So we leverage that agility of the UDP stack to allow us to move faster. Now, because at the end of the day, we still need our sessions to be transmitted in a reliable manner, we built our own reliability mechanism on it. So it's similar to TCP in the way that we still have acknowledgements and whatnot in order to determine when the data packets are sent and received, or if they're not received and things of the sort. But it's built into the ICA stack, so it's handled exclusively by Citrix components. So no components in the middle between client and VDA have anything to do with it. So there's less overhead associated with it. We can respond a lot faster rather than having to wait for receipts and acknowledgements in between every single piece of the hub. Every single hop in between client and server.
So you're relying on the application layer to decide, what order things came in and whether it even cares whether we put them back together or not, because things have moved on and we don't, we're not worried about what Bob said 30 seconds ago, right?
Yeah, pretty much.
Okay. Yeah, I wish we were there together in a room right now. I'd throw pencils at you and you could shake your head every time you got a pencil, and I'd get my acknowledgement. And then at some point you're like, just throw a bunch of pencils at me. I don't care. I'll end up with the same result. That's usually my way of showing people. Hey, Bill. Well, before I go there, I do have one question to kind of get into that mix there. Where does FrameHawk fit into all this? Is it related at all? Does it fall under you? Is it showing up in EDT, or is that just a screen? Tell me where FrameHawk went.
That was a question for me or for Bill?
I think it's a question for you, but I bet Bill wants to know this. I bet Bill has.
So that's a great question. FrameHawk. So actually, FrameHawk was removed from the product a few releases ago. I believe at some point last year. Actually, I don't remember the exact version, but FrameHawk was a UDP-based UDP-based protocol, and it was exclusively graphics focused. So it provided very little in terms of functionality, like like remote device pass through. So you couldn't do USB pass through and things like that. It was focused exclusively just on being super fast and efficient with graphics. So that was really all that FrameHawk had to do. And it was again UDP based, so it was unreliable transport as well. And it based at a high level, it allowed to provide great responsiveness and user experience in challenging networks. But it was basically just a graphics thing. It was very limited in terms of what we could do outside of the graphics realm. So we deprecated the functionality and eventually removed it from the product. The replacement for that actually is what we call EDT lossy, which basically we took EDT and then removed the reliability component from it to make it true fire and forget. So the first version of that was released actually in Q1 of this year with Virtual Apps and Desktops 2003, and it's what we called within the product loss tolerant mode. So the way that works is that we actually are able to switch the transport protocol on a per virtual channel basis rather for the entire session. So right now it only supports graphics. So when we are functioning at loss tolerant mode, what happens is the entire session is still using reliable EDT, and only the graphics virtual channel is being transported with unreliable transport. So it allows, and that's really what drives mostly of what the user perceives as user experience. So you get the quick refreshes and quick responses from a graphical standpoint, and everything else can still be transported using reliable transport. One of the key drivers behind that type of functionality is the fact that not everything is a good candidate for unreliable transport. So say, for example, you're doing a file transfer. You need to make sure that your file transports are completed, completely, right? You can't drop packets in the transfer and then expect this file to be reassembled on the other end somehow. So that still needs to be reliable transport. And of course, if you're in an unreliable network, that it will take longer, but it will complete properly. It won't, there won't be any data missing. So version 1 supports graphics, and then as we continue to improve the protocol and the stack, we'll add support for other virtual channels, like audio, for example, so we can do true and reliable audio transport for better audio quality and responsiveness. And then, again, we'll continue to evaluate the rest of the stack and see which virtual channels make sense for unreliable transport in challenging networks.
Yeah, well, that's great. That's certainly where it needs to go. Yeah. Bill, sorry, I ask you a question or ask you to jump in, then I cut you off. Do you have any thoughts or comments on this?
Well, you asked you started to ask me for my question, then you asked my question. So actually, kind of funny how we were both thinking the same thing there. But what I was going to do is just clarify with Miguel a little bit here. It sounds like what I'm hearing is that EDT is more of the reliability component of the UDP transport.
Yeah, pretty
You're
much.
eliminating slow start, you're eliminating SYNAC, all that stuff, but you've built your own reliability engine, as it were, on top of the UDP stack, kind of similar in some ways to some things Citrix has done in the past with some of their, like with PVS and the protocol that it used. It was based on UDP, wasn't it? And I think it had its own reliability elements contained therein. So that's what it sounds like this really is focused on. Is that accurate?
Yeah, at a very high level, that's pretty much it. We build our reliability component on top of UDP. Yeah.
So, guys, let's talk about this blog, because we haven't got there yet. We've just been talking about state of the union and where things came from. Miguel, it looks like in this blog we're talking about MTU discovery and being able to understand the size of the size of the packets that are coming across, and let that help determine whether EDT kicks in or it hands it off to TCP. Help us understand the blog and what we're covering here.
Sure. Yeah. So really the blog is centered on a new capability we added to EDT, which is MTU discovery. So MTU discovery, it's not something new and exclusive to us. It's a network standard that has existed for a long, long time. But it's usually something that's part of what you call your network appliances and dedicated components to network type intelligence and type of thing. What we did is go ahead.
Something real quick. You, I, and Bill all know what MTU means, but MTU, like maximum transmission unit, that's the size of the packets that are coming across the network. And a lot of people, maybe some people listening to this, don't know that in some cases we have a standard size, but some cases we make them bigger, and in many cases we make them smaller. And that really just throws everything out of whack when that happens. And I think that's really what you're addressing here is, how to that. So message transmission unit, that's the size of the data chunks that we're sending over, and that's what MTU stands for. Sorry, I wanted to just clarify that.
Yeah, that's fine. I know, and that's good to clarify. Yeah. So why did we add this capability to the product? So going back to your comment about what MTU is, the standard MTU is 1,500 bytes. And that's what we default to. It's 1,500 bytes per packet. And the reality is, though, it wasn't so much of a problem before, but it's something that became increasingly more prevalent as we saw more people work shifting and connecting from what used to be very random locations, right? Like, oh, somebody's working from home today, or working from a coffee shop, and things that used to be pretty rare in the past and now are the norm. So what that introduced into the equation is inconsistency in terms of network expectations. Not all networks are made the same. And even networks that, at least from a label perspective, you would expect to be the same, depending on the underlying components and configuration, they could actually have different characteristics. So specifically to this, the one thing that we noticed is that the maximum transmission unit that users were subjected to was actually very different in many different networks. So we used to expect that 1,500 was the standard everywhere, and that was great. But then we realized, obviously, when you have a VPN connection, for example, there is some overhead associated with that. You're encapsulating your traffic in TLS encryption or SSL encryption in the past, and what that does is that it reduces the amount of data that you can send in a single packet, because now some of that space, it's filled with the TLS encapsulation. And so now before you had 1500 bytes to yourself. Now you have to share it with the TLS tunnel, so that reduces your maximum transmission unit for the application data itself. Let's say 1350, because the remainder is used by TLS encapsulation. So what happens in that scenario? As an application, I'm not aware that there is encapsulation going on. So I still send my 1500 bytes, but then once it gets to the network layer, the VPN, let's say in this case, will take that data and we'll see it and says, well, the MTU at the network level is still 1500, but I need to wrap this data around my encapsulation layer, and I still need to send it out. But I can't take the full 1500 bytes, so I'm just going to take whatever I can, encapsulate and send it out. The remainder, I'm going to fragment the data, and then the remainder I'll send it in a separate packet. And then on the receiving end, I'll take those two fragments of the data, I'll unwrap them, reassemble them, and then that's what happens. On the TCP world, that works pretty well. On the UDP world, not so great. Implementations we've seen are inconsistent at best. And so, with all the issues that we saw with, UDP fragmentation and reassembly, that was fun, to put it that way. This type of scenario also plays out in different network environments. So VPN it's an easy one to understand, because you understand why the effective MTU is slower, because you understand that some of the space in the packet is being used for the VPN encapsulation. However, there are other scenarios that I'm honestly not familiar with the reasoning behind it. But if you look, for example, at mobile networks like 3G, 4G, LTE, they use non-standard MTUs as well. And so when you have a user connecting to a Citrix environment using a mobile hotspot or tethering from their phone, their connection will have an MTU that's lower than the 1500. And as a result, the packets will get fragmented the same way. Even actually with different Wi-Fi solutions, we found that some Wi-Fi access points, for whatever reason, they use different MTUs, and this is something that's not standard across the access points vendors by any means.
And Miguel, sometimes it's the network administrator who goes in, little terminal session, decides what the MTU is going to be, and a lot of times they don't tell anybody. And then the application owner, vendor, user, they're just getting the fallout of it with no idea what's going on.
Yeah, exactly. So that's what we are seeing is very common right now. And so, as a result, we started seeing more issues resulting from the fragmentation of EDT traffic and, UDP as a whole. And so, we came up with a workaround, which was to hard code an MTU for Citrix sessions. And that fixed the problem in the short term. Problem with that workaround is that it's a universal setting, and you're basically forcing every single user to use the same MTU, even if it's not what's optimal for them. So there are very minimal side effects to that, but the fact that you actually have to go in and configure it and try to figure out it works for everybody it's kind of a pain. So we wanted to avoid that in the future, and that's why we thought, well, you know what? Let's just let the protocol figure it out without any extra configuration required, and every single session would be able to figure out what's the best MTU for that session. So that way, no user will be subjected to a lower MTU than it should, and we'll make sure that we are always providing the maximum packet size that we can for the best performance possible. So that's really why we came to the conclusion that we needed to add this feature to the protocol. So,
hey Miguel, where does that intelligence happen, on the VDA side or on the workspace app side, or both?
It's both. So there's actually client-side components to this, as well as VDA side components to it. And the way that it works, it's actually when the feature is enabled, when the session is established, it's actually established with a very low MTU. The reason for that is we want to make sure that the session is established correctly to allow to get the user to see their desktop or application and start working right away. Now, once a session is established, in the background, we start querying the network, if you will, for what's the appropriate packet size. So we start testing various packet sizes, and we start increasing until we break, basically. And then once we figure out what's that maximum size, then we seamlessly change the MTU for the session without interrupting the user session or anything.
Okay.
Yeah, but for that to work, both the VDA and the Workspace app need to understand the feature so that they know what to do with those control packets that we send for that interrogation period, basically.
And what kind of CPU load does this additional work create? Is it measurable, or is it pretty?
It's negligible, to be completely honest. Yeah, I mean, the discovery process happens so fast anyway that even if there was a moderate CPU usage, it would be for a couple of seconds only.
Right.
Yeah.
Let's see. I do have a question going back to some of the graphics stuff you mentioned earlier, which from our previous conversation might be a little bit out of your wheelhouse. The graphics and how that associates with using the proper protocol. How much of that is benefited by things like a GPU in the server, whether it's a physical or some type of virtualized GPU? Is that something you can answer?
Well, I'm not the expert on the subject, but basically, so the benefit of having the GPU on the VDA, it's basically the same. It's the same thing at a high level of having the GPU present in your physical endpoint, right? You need a processing unit that has the capabilities of to render and process all those graphics that you are using in your session. From a Citrix perspective, we're showing the user what's happening on that VDA, right? Whether it be a workstation or server machine. But if that VDA machine doesn't have the capability to render and analyze and process the graphics accordingly, then on the receiving end, on the user side, then they're not going to see obviously anything good. So before you can actually present something presentable to the user, the machine where your workload is running has to be capable of rendering the content.
Yeah, I guess the takeaway there is no matter how efficient the transport is, if the rendering is slow or non-performant, the user's going to see that, right?
Exactly.
Yeah.
Miguel asked that question because as it relates to here, as well as the graphics, obviously if it's a Windows endpoint, the Workspace app there is probably going to be the first one that's enabled for this. And then I assume Linux after that. And then I'm doing a lot of work with Google, and this is coming up a couple times on the Google app side of things. It's a synchronous, right, or asynchronous solution where both sides have to play along here in order to take advantage of the intelligence you guys are adding in.
Yeah. So specifically for MTU discovery on EDT, right now we support it with Workspace app for Windows, starting with Workspace app version 1912. Same thing on the VDA side. So you need VDA version 1912 or later. And we are currently working on adding this capability to other client platforms. So the goal is to get all the desktop platforms taken care of. I don't have a timeline right now, but hopefully, if I can get my wishes come true, then hopefully by later this year we can accommodate that. But the immediate target would be Mac and Linux as the next platforms to support this.
No, that's great. I know you guys. It's always a conundrum, right? Because you have so many platforms that you support with the Workspace app, but at the same time, you got someone's got to come first and second and third. And
yeah. No, and that's something that we're trying to improve on as well, trying to make it easier for everybody involved to adopt newer features quicker, if not at the same time, whenever it may be possible. I think there's some stuff that we can do there to accommodate cross-platform releases. There will always be scenarios in which certain things, will have platform specific dependencies, and we'll have to, those get evaluated on a case by case basis. But that's something that we're working towards improving as well.
So, Bill, any other questions or comments here? This has been great. Anytime we can talk protocol in the world of Citrix and be technical about it, that's when true consultants in the Citrix space really get excited, because that's where the flag was planted 30 years ago. So, Bill, any additional thoughts or comments?
I think we may have lost Bill.
Yeah, we may have. So, Miguel, what else? Before we wrap up here, what else in the world of protocols at Citrix would you want to maybe just highlight here before we wrap this one up?
Sure. Yeah. I mean, so EDT MTU discovery is the latest and greatest, in the EDT stack. Again, we're working towards adding that to the other platforms, hopefully sooner rather than later, but, definitely very exciting stuff. As I mentioned earlier, another great addition to the stack in terms of transport is EDT lossy, or what you might find in the policies as loss tolerant mode. So there's more to come in that area. Again, right now we support full screen H.264 graphics with loss tolerant mode, and we will be releasing support for that through Gateway in the near future, I hope, as well as support for that protocol on the other platforms and additional virtual channels. So those are, from a transport perspective, those are the things that we are working towards right now, and we're trying to focus as much as possible on that. But yeah, lots of in HDX in general, there's a lot of great, exciting stuff coming there as well.
Yeah, I find it interesting. We're 30 years into all this, and that's really where the rubber meets the road. And you guys are still making advancements there. That's the real investment that I personally enjoy seeing from Citrix. Some of the other things are nice, but this is where where you guys make a huge impact on the space and show good leadership.
Yeah, I would agree with that. I mean, it seems like every time we have conversations like this, every 6 months or every year, it's more good stuff to come, and then 6 months later, it's been released, and then it's more good stuff to come. So it's the continued innovation is definitely welcome by us and obviously by end users.
Oh, that is great to hear. We like to add things that are actually useful to our customers and users. So to get that feedback is always great. Now that I'm thinking about it, one thing I like to call out, which is completely unrelated to EDT or transport in general, but we did release an enhancement in the product that's more geared towards security than transport enhancement or anything like that. Is we added a virtual channel allow list feature, which basically locks down the virtual channels that are allowed to be opened within a Citrix session. So, if you haven't checked that out, I definitely recommend folks and you guys as well to take a look at it. And basically what it does is that when you enable the setting, it only allows the built-in Citrix virtual channels from ever being opened within a session. If you have, if anybody were to add a custom virtual channel, those are automatically blocked. And if you're in an environment where you have your own custom virtual channel, or you have any third-party solutions that have their own custom virtual channels for integration with Citrix, those can actually be added to the list manually within the policy. That gives you control over which custom virtual channels you want to allow, rather than leaving it open. So yeah, trying, from a security standpoint, trying to, to be a little more secure and giving people more control over, what happens within their sessions and, what's allowed to come in and out. So something to look into.
Yeah, I hear custom virtual channel and just think what could possibly go wrong. But obviously there's some use cases where it does make sense. All right, Miguel, thank you for the time, man. It's been great. And keep us posted, and we'll keep an eye out for your blogs. And as you have them released, we'll definitely have you back.
Sounds good.
Miguel.
Thanks for having me, guys. Great talking to you.
Appreciate it. Thank you.
All right.
Thank you for listening to the Citrix Session with your hosts, Andy Whiteside and Bill Sutton. A special thanks to our guest for attending today's podcast. Podcast produced by Pete Downing. For any input, or if you'd like to be a part of our podcast, please email us at info@XenTegra.com. Please head over to XenTegra.com/podcast to listen to all podcasts in this series. This podcast is copyrighted by XenTegra LLC.